All right, so how's everyone doing today? It's a rhetorical question, you can't respond. So, what I'm doing here is just recording some stuff of me coding, putting together some examples of creating a kind of simple synthesizer in P5. This is for the programming digital media course before things kind of went a little haywire with this semester. Um, we were just about to get into this, so I'm kind of giving everyone just a little, just a few mini lessons, maybe two or three, nothing too crazy, about how to get into this next little section as kind of a wrap off for the course. So you can check these out if you're in this course right now. If you're not and just happen to stumble across this video online, you can use it as a tutorial for how to put stuff in your P5 project. Um, or otherwise, I'm not sure why you're here, but thanks for checking it out. All right, so I have in this window just P5, and then I have installed, if you click on the HTML file, uh, if you go down here and on this line, you can see that I have um, the Tone.js library installed. So if you don't have this line in your HTML file, none of this will work, and you'll get errors, and P5 won't know what's going on with that. Um, just as a refresher, the library is just a collection of other codes. P5, this particular file is looking at a few of them here, but without them, it's just P5. It's like it doesn't have access to that part of its brain. So if you were missing, the part of your brain that wanted to control your left arm, and you tried to control your left arm, your brain wouldn't know what to do. You'll notice I have a sound file loaded up here. That'll be for the next kind of building on this video, so I won't get into that too much. But the main part of this is you need to have the Tone.js library installed. All right. So if I go back here, I'm just going to minimize that because it'll be in the way. I have essentially the default patch opened up here. I've opened up a little bit of space in the setup, and I've added an empty call to function mouse pressed because we're going to need some of that. I've also got a line function here, and again, I'm going to kind of build on that in the next video. I just went ahead and threw it in there so I wouldn't forget. Um, all right, so before I get into how to build a synthesizer, I should talk a little bit about what the synthesizers are doing. For this particular context, we'll be doing some fairly basic synthesizers. You can get into some more complicated ones by combining different synthesizers or multiplying signal values and voltages by different things. That's a little bit outside the context of this course. Not terribly much so in a normal context, but since this is kind of a reduced version of what we normally do, I'm just kind of skim over that just a little bit. So before we left off, I mentioned that whenever anything makes a sound, you're causing some kind of vibrations. So in the case of me talking, I'm causing vibrations in my throat, and it causes if this is one air molecule and this is the other, that causes the vibrations give it energy and cause it to move and bump into the one right next to it, and then they kind of push away from each other, and then this one will bump into the next one, and so on and so on and so on until it reaches a microphone or your ears or whatever is registering to pick that up. All right, so that's what's going to happen. If you look at what's called the waveform, these kind of squiggly line representations of sound, that's kind of just a general representation of that process. So when a bunch of the air molecules are all right next to each other, they're kind of dense, kind of tightly packed. There's kind of the high pressure, which results in the high voltage. That's kind of where these things are analogous. So that line gets up to the higher point, and then when it gets down low, it gets to the lower point when they've spread apart, and so on. And this repeats over and over again. Now, the reason I'm bringing this up is because our synthesizer that we make can do four kind of main sounds. All right, and those sounds are achieved by different patterns of alternating between the high voltage and the low voltage, the high air molecule density and the loose air molecule density. All right, so that's what we have: a sine wave, where it's just a very gradual transition from high to low. the square wave, where it essentially jumps from high to low to high. Triangle is similar to a sine wave, only instead of it gradually transitioning, it jumps from high to low directly. And then the sawtooth is kind of a mix between the triangle and the square wave. It's it ramps up kind of directly and then jumps right back down instantly. Now, all of these have a specific timbre. Can't talk today, but what else is new? There, and if you go to the online class book, and I have the URL of that right here, there's a code in the synthesizers tab, which you can get to on the side right there, and you can kind of transition between each of these in order to hear them. Now, I will say that I am, at the time this video is being made, in the process of going through each of these pages and kind of updating and tweaking them. So it may end up looking a little bit differently than how it looks now, depending on when you check out this page. But this code will still be here. It will be that I like this code because it kind of shows off the different timbres, which is what I'm going to do now. I'm going to, first you have to just click in the little result box here. I'm going to start on the sine wave because that's kind of the default one to have. So you can choose the sound form you want with the buttons here, and then if you hit the numbers 1 through 8 on the keyboard, it will play a note. So I'll play a few notes here. Cool. I'll play shorter bits for the other ones, but if I transition to square, we get something like... for triangles, we have... Get that, and then for sawtooth... Find the end of that. All right, so that's the kind of the 4 generic levels of synthesizers. So synthesizers in general can do much more complex sounds by combining these different waveforms, adding them together, kind of multiplying or kind of modulating them so that different parameters control different sound outputs. You can really kind of delve into that, but again, because this is kind of a reduced version of this concept, we won't be getting too much into it. So how do we actually get into this? Well, we just so happen to have a code here that's kind of showing generally how to make this. So there's a bunch of different stuff going on. So I will kind of scroll through this just so you can kind of see it. But again, you can pull up in the page and check out the code yourself. And I'm going to kind of walk everyone through some of the important stuff in order to make this on your own. All right, so we kind of had a chance to check that out. You can always pause the video if you wanted to see that longer. But I'm going to head over to the P5 page, and I'm going to open up some new stuff. All right, start typing some things. The very first thing you have to do before you make a synthesizer is to make a variable that's going to hold all of the stuff for our synthesizer. All right, it's going to be this container that encapsulates the synthesizer so the computer can refer to it and find it later. All right, so I'm just going to say I'm just going to be real basic and call this simple synthesizer. All right, so simple synth, that's going to be our code right there. All right, so I'm just gonna move that down just a little bit. So the next thing we have to do is kind of set up and create this synthesizer. We've built the case for it, this let simple synth. Now we have to fill it in with all the components. So I'm gonna go down into setup and say that simple synth is going to be assigned. It's going to be a new Tone.synth. All right. So that's going to be there. So the synth is kind of an object inside of the tone library. That's why you have it's a new object. It's in the tone library. It's the synth. It's there. If you go and check out the reference page for the tone library, we have a whole thing here on that. But I'll get into this in just a little bit. I'm going to kind of walk you all through some of the basic things to start with. So we do need a few arguments inside of this. All right, so the very first thing, just before I forget, because I always forget, is after your parentheses, you just got to say to master. All right, so what this does is just connects your synthesizer to your master speakers for your computer. Otherwise, you'll generate all of this stuff, but you won't hear it. All right, you've kind of got this idea of passing along the signal from the start to the finish, just like when we were making our sampler project with the effects in our class, and I made a little short video about that. I'll put a link in the description just so you can kind of check it out. It's just like the dot connect or dot chain stuff. It's just sending the sound from one place to another, but dot to master is what sends it to the speakers. All right, so you want to have that right after the parentheses before your semicolon. So what you type in there is where things get a little bit more complex. So I'm going to put in some braces, move that down just a little bit, and we're going to do some stuff in the Json format, the JavaScript object notation, which again, just at its basest level is essentially the parameter of the object you want to control and the value you want to set it at. There's much more in-depth stuff. I'm not here to get into that. That's not a part of the class. It's just how this stuff is formatted. So what we need to type is what kind of oscillator we want. Remember, these sound forms that we have here, they're moving back and forth very fast, so that they're oscillating, up and down, up and down, up and down. So that's why it's an oscillator is going to generate these oscillations in a specific pattern. All right, so I'm going to type this out. This is spelled O-S-C-I-L-L-A-T. I'm a horrible speller. All right, oscillator, colon. And now this is where things, at least for me, always get a little confusing. This gets its own set of braces. And then inside of the oscillator, we have to specify the type. And then you can type in whatever you want as a string. I'm going to make it, which one do I want to do? Sawtooth sound effect. So, as I was saying, so you can have the simple synth here. We've assigned it the new Tone.synth object, and we're specifying the type of the oscillator of the Tone.synth. I'm going to give it sawtooth. So we have that there. All right, so after that, I'm going to go down to the closing brace for this oscillator, give it a comma, and we're going to put in one more thing. I'm just going to set the resonance. I'm going to put, this goes between 0 and 1. I'm going to set to 0.9 so our sound kind of has a little bit of resonance, but it does fade off after a while. All right, we've got that there. Now there's a few other parameters you can set and adjust inside of the tone synth. So if you go to that reference page, which you can check out, here's that URL. I'll have links to all this stuff in the description of the video just so you can check it out. But if I go here, oscillator type triangle, but you can also set some stuff with the envelope. You can adjust all of these things about your synthesizer. They have all of that stuff right here. I'm not going to go into much of them, but if you can always experiment on your own to get the kind of sounds that you want, they're all right here. Okay, so that's all right there. I do want to mention this envelope because that's how we kind of get the unique sound of our synthesizer. All right, so you'll notice that there are 4 specific elements, and these elements are present in just about every sound ever made in any context, okay? So what they are the attack, decay, sustain, and release. And right here I have a graph kind of showing those along with the volume of the sound. I'm just going to real quickly resize myself. There we are, so we can see all of that. So this is the volume of the sound over time. And so that's what this graph is. So every sound in some regard has an initial attack where the sound starts. And then it kind of reaches its maximum bit, kind of it's reached that threshold of existing. And then it kind of backs off just a little bit. And then it sustains for however long the sound goes. So it can be short, it can be something long like do or do. Those later examples had some much longer sustains. And then the release where the sound finally stops. All right. So that's abbreviated as ADSR sometimes, or what's referred to as the sound envelope. Now, normally making this sound in a synthesizer without any kind of envelope, the sound would just go. It would exist forever. It would essentially jump right to the sustain and then shut right off without a release. It would just be on or off. So by taking that sound and shoving it into the envelope, we're able to give it its own characteristic. That's where I was ultimately going with this. So if you go here, I'm just going to copy this for the sake of time. Copy this, do that. So if we go right after, not a period, comma, add a comma after our resonance, and paste in this. I'm just going to tidy that up so we can see it a little better. So now we have, actually, you know what? I'm going to move that down just to make it a little easier to look at. Comma. There we are. So now we have multiple levels of things. We have our oscillator of the tone.synth. We're setting it to sawtooth. You could set it to sine, triangle, square, or sawtooth. Those are your options. We have our envelope, and you can adjust these attack, decay, sustain, release values and kind of experiment a little bit with how you want your sound to tweak. I'm going to leave these with how they are for now and come back to that later once we have a working synthesizer and we can actually hear how they sound differently. And I've added just a little bit of resonance to it. That's what it is. That's there. So they eventually do that there, and then we're just sending it all to the master. So that's essentially that. So now we've built the basis of our synthesizer. So now we need to tell our computer how to trigger this. So there are many different ways to go about triggering this. You can do a keyboard example as we looked in the class book here. So with this one, if I was hitting the numbers 1 through 8, it would trigger specific notes. This is a totally fine way to do it. If you want to set specific pitch values to specific keys on your keyboard or clicking in certain things on the screen, that's totally fine. For this example, I'm just going to do one note for now and tweak it from there. So that's why I have function mouse pressed pulled up. So whenever we click on the mouse, it's going to trigger one note. So to do that, we need to talk to our synth. So simple synth dot, and this is a long one. It's going to be trigger attack release. All right, trigger attack release. All right. So what this method is just going to trigger the attack and release of our sound. All right, so I've got that there. Now you do need just a few things to put inside of here. The first one will be kind of the note that you want it to be in this case. For now, I'm just going to do one note, like I said. I'm just going to do A3. All right, and then I'm just going to type in the 1 there. So typing in the 1 will kind of adjust different parameters. That's the trigger of the attack. It's going to attack. It's going to be A3. It's going to release it off after 1 second. That's the idea. There. So what is this A3? So if you go to a keyboard, and I have an image of one pulled up. This isn't a full-size 88-key keyboard, but you'll get the idea. Each note on the keyboard has a general distinction as for what pitch it is and what octave it's in. So starting down here on the low end, we have our C1. That's a much lower sound. D, E, F, G, A, B. And then when we get back to C again, we get C2. Let me see, 3, C4, and so on. So if I were to go up onto a keyboard, we're going to be playing this A3 note. All right, we have that there. That's just the white keys on this example. If you want to have different pitches, you can specify C sharp 2 or A flat 2, saying the sharp will move it up one key to the black one right above it, or to the right, I should say, and saying flat will lower it to the one to the left. All right. Notice there is no black key between E and F or B and C. That's just how pianos are set up. And the way you would go about doing that is just when you're typing in your note name as a string, you would just say, if you wanted a sharp, you would put in a pound sign, or looks like a sharp sign. The angles are a little off, but a sharp 3. Or you could type in a flat 3 by typing in a lowercase b, because that looks like the musical symbol for flat. I'm just going to keep it as A3. So we have that there. And this should be all we need to trigger our sound on the A3 whenever we press the mouse. One thing I do want to point out is that I have this inside of function mouse pressed and not a if mouse is pressed conditional statement in the draw function. Because when the draw function happens over and over and over again, again, it defaults to 60 times a second for as long as your code is running. And the reason you don't want to have that happen there is if you click the mouse, if you've held it for even just half a second, that's still 30 times that if mouse is pressed equals true test has registered as true. So it'll try to start this synthesizer 30 times if you've held it for this just half a second on there. So you'll get a lot of kind of sound as the computer tries to restart this sound process over and over again faster than it's really capable of doing. So I've isolated this trigger inside of function mouse pressed. And if you look at the example in the synthesizers page, this is all inside of function key pressed. Because what's different about these is whenever the mouse or the key, a keyboard key is pressed, it will run whatever code you type inside of its braces only one time. All right, it's not going to happen continually. So I could press and hold a key and it'll execute the code one time, but it won't do it again until it registers that I've then pressed a key a different time. It could be the same one, it could be the different one. Doesn't matter. Same thing with the mouse. I could click it and hold it, or I could click it and let it go. It's only going to happen one time until I click the mouse again. So let's see. This should be working. I've got my little canvas here, and it works. So I click that there. Again, I have this line here just so I don't forget. That's for the next video of actually doing stuff with this. But now we've made this, and as I click, we have that that A3. We can adjust the pitch, like if I say a sharp 3, and if I rerun this code, because you have to rerun it, we have our code going up 1/2 step. I'll set this just to show you the flat. I'll say A flat, but can't type. A flat, but I wanted that to be an octave higher. If I rerun this, you now get that. A natural again. So that's why we get that there. We can move it all the way down to the... I think you all can hear that. That's really low. But I think the highest we'll get is it A6 or A7? I'll just go to A6 because that's really high. Just didn't want to hurt anyone's ears. All right, so we have that there. I'm just going to set that. I'll put it back to A4 for now. So you can adjust the pitch that way. And that's essentially just saying, hey, take this note, take this this sound we have here and play it back at this specific frequency. So it's generating these oscillating patterns. That's not the image I want. These oscillation patterns, in this case, the sawtooth. And it is essentially generating this repeated pattern at different speeds per second to create the different pitches. So the tone library has all of those specific frequencies in the background. So that's one thing I like about it, is it's a little bit easier to interact with this way, so you don't have to memorize a bunch of frequencies. You can just say, oh, I want this keyboard note, and it's there. All right, so let's just adjust the attack, decay, sustain, and release just a little bit so you can kind of check that out. So these are essentially kind of times for how long all of these take. So I'm going to set that just kind of 0.1, 0.5. I'm just going to make this sustain much lower. And we'll just play around. So now this will sound a lot different. All right, so you'll notice that the sustain is what gives it that body. If I say 0.31 and run it, we get a much longer sound. The attack, the more you increase this, the longer it takes to ramp up to that full volume. So if I increase that to 0.15 and rerun it, you notice there's more of a mwah on the front of it. By increasing the decay, that again is just increasing the time it takes from once we get the mwah to kind of go into that sustain. That was a horrible example because I was adjusting the pitch, not the volume, but you get the idea. 0.75. I'll make that a little longer so we can kind of hear some of that. That's still really short. It's kind of hard to tell them. Let me see if I can make that just 1. Yeah, a bit. Decays are generally really short. You don't really hear much of them. Sustain I've already played with. I'll set that back to I'll make that 0.5. And then I'll make this release much longer. Rerun that just so we can kind of hear. The note itself is longer, and then the fade out to nothing is also longer. So I made that just a whole lot longer than it was by default. It's just got a much more of a taper on the end of that. So kind of combining these aspects together, you can really set the details of your sounds. You can have really long sounds, really short ones. You can have them kind of gradually fade in or fade out, or have them be really punchy on the front. It's really up to you and how you want to experiment with your sounds. So that's essentially how you make a synthesizer. So if you kind of have been going through this with me, we have all of this here, and we've made a single synthesizer. Now there are several synthesizer objects inside of the Tone library. There's a few just right here. I'm not going to get into some of these, but you can do a bunch of different kinds of stuff. This is just the basic one that the other ones are built out of. So we have this going here, and all right, so I have everything here with our synthesizer. We've set up this envelope here. We can make multiple synthesizers here. Just give them, essentially, if you wanted to copy this as a template, there's no reason you can't. And in fact, I would recommend that for saving time. But as long as they each have their own unique name as a variable, you can then make multiple synthesizers. You can have multiple things happening at once. You can combine effects, different sounds happening for different things that way. You can also adjust some of these parameters. If you look in the example we have on the book here, that it says how to kind of work your way through it and change the waveform in that example. I'm not going to go into that, but there are ways to go around and update that inside of your single synthesizer if you have that there. But yeah, you can work all this out from kind of what I've shown you. So this will kind of be the first in a series of videos I'm making. If you have questions about what I'm doing, then please don't hesitate to ask. The idea is in the next video, I'm going to then show you how to add in a sequence of notes so that way you can use your synthesizer and give it a specific melody to play, and then you can trigger that in certain ways. And then the last video for this one will be to kind of how to add that into different projects. All right, so thank you very much. Stay safe, and I will see you in the next video.